Now welcome back to the new class. Here I'm going to continue the last class, magnetic effect of current and magnetism. So today I am going to share one important information to solve the numerical properly from this chapter. So first of all, magnetic field due to two concentric circular carrying same current in the same direction. So we will find out its magnetic field when there are two concentric circular current carrying loops. Here we have the two loops. Inner one has its radius R1, outer has its radius R2, and its center is O. From these two loops, the value of current flowing I, both have the same current. So magnetic field B will be equals to magnetic field due to this inner loop and plus magnetic field due to this outer loop. This will be equals to mu naught by 4 pi 2 pi I by its radius R1 plus mu naught by 4 pi 2 pi by its radius R2. Taking from common from here, this is mu naught by 4 pi 2 pi I 1 by R1 plus 1 by R2. This will gives you the value of the resulting magnitude of magnetic field due to these two circular concentric circles having the same current. But in the second one, I just want to discuss here that if the value of the current in opposite direction, now direction of the current is opposite, I here, then direction of magnetic field will be in opposite direction. So we will see that B1 minus B2. Resulting magnetic field B will be B1 minus B2, and similarly both have the same magnitude, but here you will find negative. Similarly, negative here. So this is the value of the magnetic field due to these two concentric circular carrying current loops but opposite in direction. I think it's clear. Now in third case, we are going to say that two concentric circles, but they are mutually perpendicular to each other. Their circles, their centers coincide each other. So we will see this again. Suppose we have the one loop, the center, and this is the another loop. Both loops have the same radius and same centers. This is the center. This is the axis of this loop, and this is the axis of this loop. Suppose it is X, it is Z. Its radius is R, and its radius is also R. Both have the same magnitude of current. Both have the same magnitude of current. Since both these two are identical, so their magnetic field will be same. So B1 equals to B2. Value of B1 is suppose in this direction, and value of B2 is in this direction. So this will be equals to what? Mu naught by 4 pi, this is 2 pi I by r. Its radius is r. So net magnetic field, this will be equals to B1 square plus B2 square according to laws of parallelogram of vectors. This is the direction of the B, resulting magnetic field. Then magnitude here, that will be mu naught by 4 pi 2 pi I by r, this whole square, plus mu naught by 4 pi 2 pi I by r, this whole square under root this. Now this equals to 2 into mu naught by 4 pi 2 pi I by r, this whole square under root this, and this equals to root 2 into mu naught by 4 pi 2 pi I by r. So this is here the magnetic field due to these two mutually perpendicular identical circular coils carrying the same current. Now I am going to discuss here that magnetic field due to two circles which are displaced, they are not concentric. They have some distance, means their centers have some distance from each other. This is here the coil. This is another coil, and suppose this is the reference point. From here its center, and its center is here. So this distance is x and this distance is y. Suppose x equals to y. Both have the current I. Both have the radius r. Now its magnetic field, that will be here in this direction, and its magnetic field will be in this direction. Suppose it is B1 and it is B2. So its magnitude will be in this direction, B. From here, B equals to what? B equals to mu naught by 4 pi. Now 2 pi I r square by r square plus x square, this to the power 3 by 2. Now value of B2, its B1 is this, B1 I am writing here in the place of y, this direction, x, because both are same. So B2 equals to mu naught by 4 pi 2 pi I r square by r square plus x square 3 by 2. So resulting magnetic field, that will be equals to B1 square plus B2 square under root this. So we will do the equation here. Mu naught by 4 pi 2 pi I r square by r square plus x square, this to the power 3 by 2 whole square. Then plus mu naught by 4 pi 2 pi I r square by r square plus x square, this to the power 3 by 2, this whole square, under root this. This equals to 2 into mu naught by 4 pi 2 pi I r square by r square plus x square, this to the power 3 by 2. This is the square of this, under root this, and this equals to root 2 into mu naught by 4 pi 2 pi I r square by r square plus x square, this to the power 3 by 2. This is a resulting magnitude. Now I am going to discuss here one numerical. Suppose we have a circular loop and through which some current is flowing. Suppose this is a circular loop, this is the center, and from here it is made cut, and here is the current flowing through this. Suppose I current flowing and its value is 10 ampere. This is here the radius R, this is the center O. Radius, value of radius is equals to 3 centimeter. Now we are going to find out the magnetic field due to this portion of the loop. So first of all, we should know here that length of this portion of the loop, if this angle is 90 degrees, then we can find this portion according to L equals to theta equals to L by R. So L dash, length this L dash equals to R theta, and theta equals to 90 degree pi by 2. So we can say, right, R into pi by 2, this is pi R by 2. Now think over this length. This length will be here total circumference minus this. So length of this wire, this portion, that will be 2 pi R minus pi R by 2. This is the length of this portion. This equals to 3 pi R by 2, and this may be written here as 3 by 4 into 2 pi R, multiplying and dividing by 2 here. Now magnetic field due to whole circular wire or coil, that will be equals to B. This is mu naught by 4 pi 2 pi I by its radius R. So now we are going to find out the value of this one now. So magnetic field due to this portion of the wire is B dash, and equals to, it is 3 by 4 into B, because the length of the wire is 3/4 of the total circumference. So it is now 3 by 4 into this mu naught by 4 pi into 2 pi I by R. Now putting the values, 3 by 4 into, and its value is 7.5, 10 to the power minus 7 into 2 into 3.14 into 10 ampere by its radius. Radius is 3 centimeter, so we can say 3 into 10 to the power minus 2 meter. So we will write 3 into 10 to the power minus 2. After simplification of this portion, we will get 1.57 into 10 to the power minus 4 Tesla. This type of questions may be asked in CBSE board examinations and also in different competitive examinations. So I think that you should prepare for this one and do the practice. We will meet again in the next class.